Here is your script for 12 network protocols, explained using a real mesh network. It is designed for a 240-second voiceover, 600 words, with a flowing, conversational tone and short, punchy sentences. Visual, fast-cut montage of a glowing network rack, a Raspberry Pi blinking, a phone screen showing a mesh dashboard. Text overlay slams in, 12 protocols. One real network. Stop me if this sounds familiar. Your Wi-Fi is down, and you have no idea why. Most people see a blinking router. I see a war zone of protocols. Today, I'm going to show you 12 of them fighting for survival on my real mesh network. No simulations. No pretty diagrams. Just 8 devices talking right now. Visual, animated map of the mesh with IP address labels popping up next to each device icon. 1. IP, ***, everything starts with an address. My Raspberry Pi is the brain at 10.0.10.50. My OnePlus phone sits at 10.0.10.220. Without IP, these packets would just be screaming into the void. Visual, a tiny shout bubble bouncing between the PC and Pi. Highlight the MAC address label. 2. ARP, ***, but IP is logical. The network needs physical addresses. When my Windows PC wants to talk to the Pi, it uses ARP to shout, "Who owns 10.0.10.50? The Pi answers with its MAC address. It's a digital doorbell. Visual, ESP32 S3 board with a pulsing green LED. A line graph showing uptime. 3. ICMP, ***, speaking of knocking. My ESP32 S3 runs the watchdog. Every 30 seconds, it pings the Pi using ICMP echo requests. If there's no reply, the alert goes off. It's the heartbeat of the whole mesh. Visual, a phone joining the network. A DHCP message flows from the phone to the router, then to Pi-hole, then back with an IP address. 4. DHCP, ***, when that phone joined, it didn't have an address. The D-Link router relayed the request to Pi-hole, which handed out a lease from the 100 to 200 range. That's how the phone got 10.0.10.220. Config-free networking. Visual, a browser typing jackche.com. The request hits Pi-hole, which shows a list of blocked trackers and returns a clean IP. 5. DNS ***. Now, when I want to reach the dashboard, I type a name, jackche.com. The Pi-hole at 0.54 resolves that instantly. It's my local directory. And it blocks add domains while it's at it. Visual, a split screen showing a large file transfer, data packets numbered and reassembled in order. 6. TCP, ***, not all traffic is created equal. For reliable data, we use TCP. SSH, web pages, API calls, they all ride on TCP. If a packet drops, TCP resends it. Guaranteed delivery, every single time. Visual, fast-moving packets with no return receipts. Highlight DNS and DHCP labels. 7. UDP, ***, but TCP is heavy. For speed, we use UDP. Fire and forget. DNS queries and DHCP leases use UDP because they're small. If a packet is lost, you just ask again. Milliseconds matter here. Visual, a terminal window opening an SSH session to a grid of server icons, keys rotating into place. 8. SSH ***. This is my remote control. The Raspberry Pi connects passwordless to all 8 nodes using SSH. No passwords. Just cryptographic keys. From here, I can reboot my Ubuntu VM or check the Redmi phone, all from the command line. Visual, ESP32 displaying get/status on a tiny screen. HTTP label flashing. 9. HTTP ***. Inside the mesh, we keep things simple. The command API runs on plain HTTP. The ESP32 sends a GET request to the Pi at port 9092. It's local, fast, and unencrypted, because it never leaves the house. Visual, a WebSocket pipeline showing continuous two-way arrows streaming to the dashboard. 10. WebSocket ***, but HTTP is a one-shot request. For live updates, the ESP32 opens a WebSocket to port 9092. It polls every 30 seconds, but the connection stays open. The server pushes instant status changes. No reconnect overhead. Visual, a globe turning into a secure tunnel entering the house and connecting to the Pi. 11. HTTPS ***. Outside the mesh, I don't trust anyone. I use a Cloudflare tunnel. Omni.jackshay.com points to the tunnel, which encrypts everything back to my Pi. The Redmi phone connects through this tunnel only, 0 open ports. Visual, a padlock locking over the same tunnel. Show the TLS handshake as 2 keys meeting. 12. TLS ***. That padlock is TLS. It's the engine under HTTPS. The certificate check, the handshake, the encrypted session, it all happens in under a second. It's how the tunnel keeps my commands private. Visual, all 12 protocol names fly together and form a mesh grid, glowing. Text, sources below. These 12 protocols are working together right now, in perfect silence. The IPs, the pings, the handshakes. Next time your Wi-Fi drops, you'll know exactly who to blame. Sources ***. https://en.wikipedia.org/wiki/internet_protocol. https://en.wikipedia.org/wiki/dynamic_host_configuration_protocol. https://en.wikipedia.org/wiki/domain_name_system. https://en.wikipedia.org/wiki/secure_shell. https://en.wikipedia.org/wiki/WebSocket.